is Nat Maven. Today we'll illustrate how easy it is to configure an NX OS, a classic non-VXLAN fabric using the NDFC Cisco Nexus dashboard controller. We'll configure address, RP, OSPF, and a VPC using the Nexus dashboard fabric controller. In the end, we'll verify the connectivity using ICMP between the hosts that are connected to the fabric. So what is NDFC? Nexus dashboard controller provides a fabric-oriented configuration and operations management. I can optimize it for large deployments with little overhead, but it also supports traditional deployments, and I can customize it to meet the business needs. The Nexus dashboard controller also will provide the RESTful API to allow easy integration from Cisco or third-party overlay managers and enable the automation to meet everybody's needs. This is automation platform. Nexus dashboard controller will bring an easy to understand and simple deployment approach to bootstrapping a new fabric, whether it's VXLAN, UPN, or traditional non-VXLAN classic network. The Cisco best practices are built into the fabric builder policy templates. With a click of a button, I will launch an automatic bootstrap, reducing the provisioning times and simplifying the deployment. The fabric controller then will maintain an active topology, monitoring views per fabric into new fabric UI. So when combined with Nexus dashboard insights NDI, it can implement the solution with advanced support for day 2 operations. The first step, we're going to add a fabric. Then we'll configure is the VPCs, and we'll configure the VLAN interface with HSRP. Then we'll configure the OSPF between the CSR, is my CSR router, and here my spine and leaf fabric. We'll then configure the VMM, and we'll configure remaining the VPCs. Alright, stay tuned. We are going to add the fabric into the Nexus dashboard controller. We'll build the fabric that the fabric controller manages. Click the LAN in the fabric controller, and we'll click fabric. Take action to create a fabric. This asking me the fabric name, so we'll say it's classic LAN fabric, and we'll choose the template. The template, so from the drop down, we want to use is external fabric. It's the fabric template support Nexus and the non-Nexus device. Click select the AS number 65001. Under, then we'll uncheck the fabric monitor mode, so that's fine. Uncheck this option will allow me to configure the fabric rather than just monitoring it. Okay, and we'll click save. In the fabric LAN list, then double click this fabric, classic LAN fabric, and we're going to add switches. In the fabric overview page, we'll click the switches. Then in the switches display, we're going to click action, and we're going to add switches. In the inventory management dialog, here we have the seed IP. Enter the seed IP, username, password, and we'll click Discover Switches. We're going to select the manageable components and we'll click the switches, leaf 2, spine 1, spine 2, leaf 1, and click Add Switches. When the progress indicators for all components display switch added, then we're going to close this. Close the page. Close that page too, and hold over to topology, click the classic fabric. Make a little bit of organized topology. Now here you go, is show you the topology. I will drag and select and drag the components to match the image here, like this. Okay. Now we're going to add a CSRs, the CSR routers. So what we do, we will go to Fabric. We'll still click the classic LAN fabric. On the switches, we're going to add switches. Inventory, here we use the seized IP. Okay. Discover switches. So it's going to find the CSR routers, and we'll have to add into Fabric controller. Alright, it shows as an MPv3 timeout. That's okay, we're going to add it one more time. This time we're going to pick his iOS axis. Version is CSR. Let's see. If it's not NXOS, please pick the iOS axis. Discover the routers again. Choose my CSR. Add that router. Alright, let's add the routers. Close it. The next step is to assign the roles for my leaf. Action, set a role. The role we're going to pick is access. It's not a leaf because it's non-VXLAN. Okay, then it becomes access. Click a spine. We're going to set a role to be aggregation. Then click my CSR routers. This role will be my core router. Choose core router, select. So as this time, we have made this one my core router in this level. my spine here is my aggregate level, and the leaves will be my access layer. All right. Okay, now we'll close this, click it again, take an action, we'll take a recalculate and deploy. After that, click deploy all. This is going to make all components in sync. On upper right here, we see deploy completed. Click close. Go to the switches. We'll see the router, the access, the aggregation spines. They are in place. We have built the fabric for the rest of the lab. Then we'll configure is my VPC. Let's review the lab topology. We'll see the port numbers between the spines and the leaves. We need those to configure my VPCs. In this lab, we configure two VPC domain. First, we configure VPC domain 200 here between the spine 1 and the spine 2. Then we'll configure the VPC domain 100 between my leaf 1 and to leaf 2. So doing this configuration, we'll cover these VPC concepts. So we'll have 5 components. What is called is VPC. First, VPC. The VPC will refers to the combined port channel between the VPC peer devices and the downstream device. And next component is VPC peer switch. What is peer switch? The VPC peer switch is one of a pair of switches that are connected to the special port channel known as the VPC peer link. So one device that I configure as the primary device, and the other will be the second device. Primary and secondary is the peer switch. And another one is called VPC peer link. Peer link is the link that are used to synchronize status and between the VPC peer devices. So the VPC peer link carries control traffic between two VPC switches and also carries multicast and broadcast data traffic. In some link failure scenario, it also carries unicast traffic. The peer links need at least two 10 gig Ethernet interface each, which is the link we're talking about here. And next components, we'll talk about VPC peer switch peer link. Next is the VPC peer keep live link. So keep live link monitors the vitality of a VPC peer switch. So the peer keep alive link sends periodic keep alive messages between the VPC peer devices. The VPC peer keep alive link can be management interface or switch virtual interface. It can be, the MGMT interface, or it can be SVI. So no data or synchronization traffic moves over the VPC peer keep alive link. The only traffic on this link is a message that indicates that the originating switch is operating and running VPC. No owning traffic is owning keep alive. We'll talk about the next components. We did not say that. The last component is VPC member port. Okay, member port. Is VPC member ports are the interface that belong to the VPCs. For example, we have this port, this port, this port, this port, this port, this port. In access layer, these are all, VPC member ports. Let's start configure, the VPC. On switches, we'll configure VPC peer for the spines. Let's click the box next to the spine 1, and only the spine 1 we're gonna to click VPC pairing. We'll have to select VPC pair for what? For spine 1. That's spine 2. Then in the template, we have to pick VPC pair. And we're going to select VPC domain number. We say no, is 200. IP address is keep alive local is its own management ports interface IP, and peer 2 IP. VPC keep alive VRF name, we're gonna make management, and we're gonna leave all fields value unchanged. Okay, save. Alright, so next name, click VPC peer link. We know the peer port channel ID is 200. We're gonna make 200 in here. 200 for the interface 11 and 12. So peer link member interface, remember, is 11 and E12. Similar, we're gonna make it the same interface number for the spine 2. I will leave active as port channel mode. Give a description, so link to spine 2 peer 2. Let's link to spine 1. Click save this time. So next, we'll click leave 1. Okay, take action. So VPC pairing, and pairing with leave 2 templates VPC pair as template. First, VPC domain is 100. Keep alive local address for peer 1 for leave 1. Peer 2 VPC keep alive IP. VF name similar management. We're down here. Next, go to VPC peer link. That's 100. Member interface is the same. 102. Domain name is 100. Link to leave 2. That's description. Link to leave 1. Leave the port channel mode at active. Click save. Now we see we have 4 switches pending implementation. Well then, take action. Here, top action. Or we could say select at least switches. Calculate. Here saying Oliver sync. We'll see the configuration pending to deploy all. Now configurations were executed. Close that. Now let's log on to leave 1 and spine 1. Here, show VPC. We see VPC domain ID is 200. On leave 1, show VPC. Back to my controller. Refresh. Here it's showing spine 1 and spine 2 VPC roles setting up as primary and secondary. That's fine. Now, so show VPC. We'll see the peer adjacency formed OK and port channel peer link port channel 200 is up. So now we're just waiting for the leaves to come up. Now peer link adjacency formed OK. We just need a little bit of time. Then we now configure VPC on the member ports. First, we configure VPC on spine 1 and spine 2 on the spine ports that are connected to the leaves. Then we'll configure the leaf 1 and leaf 2 on the leaf ports that are connected to the spines. First, we're going to create an interface between the spines and the leaves. So go back to my controller, navigate to interfaces. The action is to create an interface. We're creating a VPC instead of port channel, creating VPC. What we'll do is spine 1 and spine 2. VPC ID is 20. So this 20. The policy we want to pick is interface VPC trunk host, and we enable configuration mirroring. This will replicate the configuration for both spines. So peer 1 member interface, this 1.3 and a 1.4, similar 1.3 and a 1.4. Okay. E13, comma E14. Here, mirror to peer 2. Enable BBDO guards. Say no, we don't want it because there's spines and the leaves. MTU, we use default instead of jumbo. Peer 1, trunk allow VLAN. We want to allow all. Then we click Save. Click Preview. To preview the status that the system uses to configure the interface. Here you go. To show both interface, we're gonna select interface in the switch drop down here. Okay. Now close. Click Deploy to create that interface. Port check VPC. Deployed. Complete. We can see the VPC. Log on to CLI. Go to spine 1. Now show VPC. The port channel 20 has a down, right? Down, but it will change after we configure the leaves. Okay, then we're going to create an added interface. VPC. This time we use leaf 2, leaf 1. VPC ID 10. This 20, 20. This will be 10, 10. Configure mirroring. Policy. Inter VPC trunk. Host. This is the policy. Member will be 1, 5 and 1, 6. 1, 5 and 1, 6. BBDU, no. Default. Allow VLAN, say all. Save that. Preview. Okay. Deploy. Deploy the config. Close that. Now back to spine 1, spine 2, spine 1 doesn't matter. You see the port channel 20 is up. Spine 2. Show VPC is showing success. Leaf 1, show VPC. Port channel 10, success. Leaf 2. Show VPC is now up. At this phase, I have successfully configured the spine and the leaf VPCs. VPC is done. The next thing we're going to configure VLAN interface with HSRP. In this part, we're going to review the topology and VLAN between the spine 1 and spine 2, and I needed that information to configure the spines. So in this app, I'll configure the VLAN interface between this is spine 1 and spine 2 with this all HSRP information. Back to interface. We're gonna create interface. Block button. The interface we create is an SVI. Device is on the spine 1. VLAN will be 10. And the policy we're gonna pick is interface VLAN. In the general parameters, we'll find is the VLAN interface IP. In here, we're going to enter 10.10.10.1. The length 24. Go to advanced. Click check HSIP flag. The HSIP IPv4 address is 10.10.10.254. Make a group 10. Priority says 50. We're going to enable prompt. Click save and preview. Here we have configuration pending. Click deploy. Right, close it. We're gonna repeat. Create interface for the spine 2. VLAN same 10. Policy template is interface VLAN. IP 10.10.10.2. 24 advanced enable HSIP 10.10.10.254. Same group 10. Save. Deploy. Deploy complete. Go to spine. Go to my spine 1. Show HSRP. We'll take a look at group 10. Here's the config, virtual IP and active router IP. Show HSRP. There's a display for spine 1. Spine 1 is standby. You will see the spine 1 is a standby. Go. And my spine 2 is active. Because we set spine 1 priority is 50, default priority will be 100 here. So spine 2 is my, the active. For now, we complete the VLAN 10 and we're going to repeat the steps for the spine 1 and spine 2 for the VLAN 20 using the information here provided. Okay. Close that. We're going to create the other interface. SVI. Saying spine 1. 20. Interface VLAN. IP 20.20.20.1/24. Advanced, enable the flag 20.20.20.254. Group is 20. Make priority 50. Spine 1 is gonna be a standby. Enable preempt. Save, deploy. Close it. Create SVI for my spine 2. VLAN is 20. Template. Pick interface VLAN. IP 10.20.20.20.2. 20.20.20.254. Group is 20. Priority number, say 100. Check preempt. Save. Deploy. Alright, the two groups are deployed. Log on to my spine 1, show HSRP. It should be priority 50, 50, standby. Listening, wait, speak. It's gonna come up. Okay, spine 2 becomes active for the VLAN 20, group 20. Now we'll show on spine 1 is standby now. So the status in HSRP will from initial to learn. Learn is gonna to learn virtual IP, and it goes to listen. Is listening hello messages from other HSRP device. Then we'll go to speak. Speak mode is sending hello messages and participating in the election to become active router. If it is standby, and you will just prepare to take over if active router fails or it becomes active, and listen intended for ready to receive and send the data intended for the VIP. Okay, that's a little bit of knowledge about HSRP. Now we'll take a look at the diagram. It has very good view in topology. Click it, change the configuration, and here you go. The diagram refreshes and it shows the newly configured VLANs between the spines. Here you go. VPC. For the next part, we're going to configure the OSPF between the CSRs and the spines. But let's take a look at the diagram here. OSPF connections between CSR and the spines. I will need information here to configure the spines. The OSPF for the interface on the spine 1 and spine 2 towards these, the CSR. Back to my fabric. the OSPF will have to configure to the policy, OSPF policy. Click policy. We're going to create a policy. From the switch list, we'll pick a spine 1. Okay, select. Choose the template. We'll find the feature OSPF. Click Save. We're going to repeat. Add a policy. Same thing, we'll use spine 1. The templates picking is here. We're gonna pick is the base OSPF. Select. Into 100 as a process tag. 1.1.1 is my rootback IP for the route ID. Click Save. We're going to add a new policies for my spine 2. Save. Pick spine 2. Make base OSPF. Process ID send 100. Route back IP 2.2.2. Click Save. Action. Deploy. Recalculate. Deploy. And this is going to enable SPF on the spine 1 and 2. Configuration executed, completed, deployed. Now go to the interfaces. First to find is the port 1/5 on my spine 1. Find device name, future spine 1. Here, spine 1 is not 5. Take action. Click Edit. Pick a policy that we'll have to pick is the interface routed host. Select this policy. Interface IP 10.10.40.2 MTU, reduce it to 1500. Scroll down, keep scrolling down. Here, freeform IP router OSPF 100, area 0, no shut. The freeform configuration contains enables the OSPF in the router, starts the configuration mode, then configure interface 1/5 on the spine 1. Here, we're configuring this interface. Okay. Save that config. Deploy. Now deploy complete. Let's go to spine 1, show IP OSPF neighbor. We'll have a neighbor established. That's the neighbor with my CSR1. This neighbor is formed. Go to spine 2, show IP OSPF. It's here. Show IP OSPF neighbor. Don't have neighbor, that we'll have to configure. Close this. We're gonna filter device name to spine 2. Similar, find interface 1/5. Find its interface. We'll add it to this port. Give it interface. .10.10.60.2. Reduce MTU to 1500. Scroll down, freeform config. No shut. Save it. Close this. We added the interface 1/5 and it's showing when pending. Now is to configure 1/6. Find a 1/6. Add it. IP. Scroll down. IP router OSPF 100, area 0, no shut. Okay, save, deploy it. Close this. Now we have to deploy 1.5. Deploy this. Deploy. Alright, now this two interface has been deployed. We'll go to the spine 2. Show IP or SPF neighbor. Log into spine 2. Show IP or SPF. Yes. Here we have a neighbor, the OSPF configuration has been completed. The next part is to configure VMM. We're going to take a look at the diagram. Here, connections between the server and the leaves. I will need the information to configure the leaves with the VMM on the server. That's VMM on the server. In the virtualized environment, any kind of troubleshooting starts with identifying the network attachment points for the virtual machines. This means that a quick determination of the server, a virtual switch, port group, VLAN, associated network switch, and the physical port is critical. This requires multiple touch points and interactions between the server and the network administrator, as well as referring multiple tools. This lab will configure the VM integration with the NDFC and allows us to virtualize the very center manages host and their leaf, switches, connections in topology window. The virtualization option will have only attached physical ports, only in the VM or both. When I select both, the topology from the leaf switches to the VM, including virtual server switches, displays to which Cisco NDFC supports the host running on the UCS type B, the chassis UCS, so that are behind the fabric interconnection. So I have to enable CDP of the VNIC on Cisco UCS manager to use the feature. So in NDFC, navigate to virtual management, virtual infrastructure manager, take an action, we'll add instance, select the type called vCenter, vCenter client server IP address 192.18.133.30 password. Add. Alright, successful add instance. The server that I configured is added to the list, and the status column is showing OK. Now, take a look at the topology for now. Click configuration. Here you go, the servers. Server 2. Click compute. Now here you go. There's the display. Components connected through the EXSI to the leaves. Alright, seeing enough here, go to the fabric. Click LAN, interfaces. Here we're going to filter first device, which is my leaf 1. Find out the ports. 14, port 14. Add this port. Pick interface trunk host. Select this import interface. In the general information tab here, enable PDU guards. We say no. We're going to enable port type fast. Uncheck the MTU. Pick a default. We want to allow every VLAN. Say yes. Save here. And deploy this configuration on the ports 1/4. It's been configured, and now we log on to server 1, and I would like to ping the IP 20.20.20.254. Okay. Log on to server 1, ping 20.20.20.254. Here's ping. I successfully got a response from the ping that confirms the server 1 can ping its default gateway. Because HSRP WIP, this HS WIP, this WIP is default gateway for the servers. We have to advertise it in OSPF for servers to reach the web host, which is the indifferent subnet. To do that, we will navigate to controller, still in the interface. This time we'll filter device name, spine 1. They're going to show me all the interface on the spine 1. Now find VLAN 20. Click here, add it. Scroll down, freeform configuration, IP router, OSPF 100, area 0. Click save, deploy. After that, click the web host is located here. Then I will try to ping this SVI. Ping 20.20.20.254. Yes, it's reachable. Come here, close this. We're going to repeat the same step for the spine 2. VLAN 20, add it, down, IP router, OSPF 100, area 0. All right. So now back to server 1, and then I see we can ping the web server. Here you go. So from server 1, I can ping either from here to here or from spine 1 or 2 to reach out to the web server. But go to web server, see if we can ping VLAN 10 SVI. I can't. So we have still need to advertise. But before that, let me do one more verifying. Navigate to leaf 1. Here we go. Show system internal L2 forwarder MAC. So in here, the preceding command is specific to the Nexus 9000, and it's equivalent to show the show MAC address table, right? So now take a look. 1/4 is the MAC address that I got. 1/4 is this interface, and it should show the MAC address of my server 1. Go to server 1. ifconfig Ethernet 1, and it shows confirmed MAC address for the interface that we displayed in the show commands internal L2 forwarder MAC on Ethernet 1/4. Great, we have successfully configured the VNM and VLANs. Here we're going to take care of the remaining VPCs. Where you see the VPC connection is between the server 3 and leaf 1 and 2. Here is 1, here is 1. And the information here we're going to configure this fabric. We must configure the VPC and the test the connectivity from the server 3 to the web host. And that verifies we have a configured device correctly. Now go back to interfaces. Here we're going to create an interface. We're going to pick the VPC because here's the way creating a VPC. The pair will be leaf 1, leaf 2, and leaf 1. VPC we use is VPC ID 5055. Okay, 55. Policy we'll pick is the inter VPC trunk host. That's correct. Mirror it. No, in mirror because this is the different port number. So here, let's deploy the configuration. All right, let's log on to leaf 1. Show VPC. Here, port 55 is up. Show VPC. On leaf 2, yes, it's up. Now we have to advertise this VLAN, VLAN 10 into OSPF. To do that, close this. We'll find the interface. Device name. First, that's spine 1. and find the VLAN 10. Click Edit. Scroll down, freeform config, IP router, OSPF 100, area 0. Save. Deploy it. Click close. We'll repeat the configuration again on my device, that is spine 2 VLAN 10, edit, scroll down, IP router, OSPF 100, area 0. Save, deploy the config. After that all done, we're gonna log on to the server 3 and we'll ping the web host. Server 3, ping the web host IP. So first I'll ping the gateway, yes. Then ping the web host. Yes, I could ping. I will successfully configure the VLAN 10 and completed define the fabric for the lab.